The first question here, and they say we should explain in words why the following vectors are not bases for the given vectors or vector spaces. And then they say solve by using inspection. If we check, obviously we're not going to inspect, we're going to do step by step, right? Because we're trying to understand what's happening. But by inspecting, if we take this vector minus this vector, if we say 3, 2, 1 minus 2, 1, 0, this will be equal to 3 minus 2, 2 minus 1, 1 minus 0, which this will be equal to 5, 1, 1. We say right? So the third vector can be expressed as a linear combination of vector 1 and vector 2. We say right now. So this thing cannot be a basis. So it cannot be a basis. So let's check by step by step and see how would we do it if they had asked us to check if this is a basis or not. If they had asked us to check if this is a basis or not, for A, if they had asked if this is a basis or not, we're going to do this. We're going to come to S and let first, like they say that S is equal to this in R3. We're going to let these ones. We're going to let A, this is what is R3, so it means that R3 should be in this format, A, B, C, element of R3. If someone comes and let this is wrong. You see, right? This is wrong. It should be in a space. The moment we have R2, R3 and above, it should be in a space. If we come and let this is wrong. You see, right? Because here they're talking about what? R3. So this would be wrong. Initially, this is correct, but it's wrong because we are doing it in the wrong space. You see, right? So that is not allowed. Even this one is not allowed. So from here, we let this be an element of R3 such that this vector can be expressed such that this vector can be expressed as a linear combination of these ones together with their coordinates, meaning their scalars. So we say this would be x 3, 2, 1 plus y minus 2, 1, 0 plus z 5, 1, 1. Right? Then we simplify the right hand side. We say that this will be 3x minus 2y plus 5z. In other words, I'm adding the first entries. Just skipping a certain step there. Adding these first entries. Then the second one is 2x plus y plus z. Then adding the third entries. Y times 1. Z times 1 is this. Y times 1 is this. 2 times x here is this. Then add the last ones, which is x plus z, because here there's no y. 0 times y is 0. So this side I have A, B, C. Now I equate the first ones, equate the second ones, equate the third entries. Now I'm going to do that. We know that in this case A will be equal to 3x minus 2y plus 5z. In most cases this would be us checking a spanning, right? The method which I'm using here, this would be us checking a spanning. So we would need to check if this is a spanning set. So this is how you do it, right? But in this case, I'm not labeling that because I want us to use the determinant method. So I'm not gonna say anything there. I'm just gonna use the method without saying it's a spanning set. So say that this is 2x plus y plus z. Then the C1, it's x plus z. Now this can be written in this format. Remember I said that we're gonna write it in this format, ax equals to b, which that is 3 minus 2, 5, taking these coefficients. You see right now? Then this is 2, 1, 1. Then this is 1. We don't have y, so it's 0 here. Then 1 here from z. Times our scalars, remember our scalars were x, y, z. So here I'm putting the scalars here. X, y, z. Which is equals to our equated vector is ABC. ABC. Then we say that we can check the determinant to see if this spans or not, right? And also to check if it's linearly independent or not. So to check the determinant, we first need to write it like this, in this format. This is 3 minus 2, 5, 2, 1, 1, 1, 0, 1. If someone was to say this, they are wrong for a determinant. You can't use these brackets for a determinant, and you can't use square brackets for a determinant. Use this. You see, right? So I'm just correcting this based on those who sent solutions yesterday. Then we're going to use Gaussian elimination, says that we have to highlight the diagonal entries. Then we change anything below to a 0, meaning that we are changing this to an upper triangular matrix. So we copy the first one. Using Gaussian elimination, remember we're going to change the first number to a 1. So we need row 2 minus row 1. Then we check the constant of row 2 is 2. The constant of row 3 is 3. Then if I divide here, I'm going to get 2 over 3. Then take this 2 over 3, give it to row 1. Right? Then let me erase this. And then check this one. It's row 3 minus row 1. The constant there of row 3 is 1. The constant of row 1 is 3. If I divide, I'm going to get 1 over 3. Take this constant, give it to row 1. You see, right? I don't want to hear anyone crying about Gaussian elimination, because this is the simplest method in history. So from here, we can calculate that this will be a 0. Automatically this is 0, but you need to plug for you to confirm if it will be a 0. If we check this one, right, we see that it's 2 minus 3 over 2 using this formula. Then I plug a 3 there. This 3 will don't cancel. Oh, it's 3 over 2. It's 2 over 3, man. This formula. Then this must cancel this. Then I'll be left with 2 minus 2, which is a 0. We see from there to give us a 0, right? And then this will be a 0, 0. So we know that this one also will be a 0 because the 3 will be cancelled and 1 minus 1 is a 0. Then we come to this one. Let's do this. So we start with this one. It's a 1 minus, using this formula. 1 minus 2 over 3 times minus 2. This will be 1 minus, let me have a calculator fast. 1 minus 2 over 3 minus 2. This will be 7 over 3. Then this, the second one, it's 1 minus 2 over 3 into 5. So this will be minus 7 over 3. So I have 7 over 3 and minus 7 over 3, right? So let's cancel out. And minus 7 over 3. Then we come to the last one. This one is simple to check. It will be 2 over 3. Then 1, yeah, this one is the same as this one, because these two are the same. So now we highlight also the diagonal entries. Okay, here we had highlighted. Now we need to change this one to a 0 now. So we draw this. It's 3 minus 2, 5, 0, 7 over 3, minus 7 over 3. And then change this to a 0, it's a row 3 minus row 2. The constant of row 3 is 2 over 3 of row 2 is 7 over 3. Then we divide. When we divide this, we're going to have, If I change this to a multiplication, this will become a 3, this will become a 7. The 3 will cancel, I'll have 2 over 7. Let's confirm that. It's 2 over 3 divided by 7 over 3. And that is a 2 over 3. Yeah, so this will be 2 over 7. I put it here, right? And then when I put it there, I know that when I come to apply it, this will be a 0. This will be a 0. And if I apply this one, minus 7 over 3, minus 2 over 7, 7 over 3. This will be equals to, the 7 will cancel out, minus 7 over 3, minus, what's plus 2 over 3. Then this will give us a minus 5 over 3. You can try to check the determinant of this if it is correct. What do you get, boy? Check the determinant there. What? You're getting what is it? Why are we not getting a 0? Let's check. Why? Let me see if I calculated correctly. We have 1 minus 2 over 3 into minus 2. This is correct. 7 over 3. And then we have, it's supposed to give us a 0 so that we can see that it does not span. Minus 5 minus 7 over 3. This is correct. Let's check the last one below. This is 0 minus 1 over 3 minus 2. This is correct. Let's check the last one. This is also correct. Now the problem is here with this formula. Let's verify. Let me check again if this is, so it means that this is going to be, let me check, it's for me to change this to a 0, it's row 3 minus row 2. Then if I take 2 over 3, the concept of row 3, then I take 7 over 3, the concept of row 2, I divide them. I'm going to get 2 over 7, right? Yeah, it's 2 over 7. 7 over 3. Not minus, no, divide. 2 over 7. The formula is correct. Let me see what was wrong here. Then this will be minus 7 over 3. 2 over 7. 2 over 7 minus 7 over 3. Oh, this was 2. Yeah, I had plugged here as a 7. Yeah, it's correct because this cancels this. We're left with this, right? Which is plus 2 over 3. Then minus 2 over 3 plus 2 over 3. This is a 0. It's correct. And then here we're going to have, if at the end, remember, we are not allowed to have a 0 here. You say, right? The only place we're allowed to have a 0 is this one. You say, right? So here we're not allowed to have a 0. Those two. Whenever you have a 0 here, it tells you that you should swap. You remember what happened there when we were doing an example where we had to swap the 0 with something? Yeah, it was here. We swap these 2 rows. Then we got this. Alright, maybe that's still visible there. And then it ended. Can you still see there? Alright, let me finish. Just finish here. 3 times 0, this will be equals to 0. Meaning the system is inconsistent. If the system is inconsistent, it means that we did was what? It was S, right? S does not span R3 and there is not linearly independent.